Hey guys, lesson 2-3 is looking at factored form of a quadratic equation, okay, or of a quadratic function. So we're going to start off with, okay, let's review just the basic factoring, and then we'll move into, okay, how do we solve equations when we're factoring by using the factoring method. So that is pretty much the big gist of things. I mean, yes, we have a few other things to look at along the way, but we're looking at the factored form here. So, dig deep into those Algebra 1 brains.
I remember.
Because this factoring I'm going to teach today is all Algebra 1 review. We've done this all, okay? So, first one we're going to work with. X squared plus 7x plus 12. Thoughts on how to factor it?
Doesn't. Oh, I remember.
No, you don't.
Okay.
What do you remember?
So the two numbers have to add up to equal the middle number, but multiply to equal the last number.
Okay.
So it's 4 and 3 on the first one.
Okay.
Oh, he's right.
If what he's saying is making any sense at all, yes, I agree with what he's saying. Okay, he's on the right track. So this one, so first of all, it's in your typical, what I would say, quadratic trinomial. It's quadratic because it's x to the second, yes. Trinomial because there's three terms. There's an x squared term, an x term, and a number term. And we want them in that order. And then I call this, when I say we're going to factor this, I say product and sum. Okay? I'm going to say, okay, we want two numbers that give me a product of the C value. What's my C value?
12.
12. And then I want the same two numbers that give me a product of 12 to give me a sum of the B term. What's in the B position? 7. So it'll always be product of the last number, sum of the middle number. Now, what do I mean product? Landon didn't use the word product, did he? What did he say?
Multiply.
Multiply. Do you prefer multiply?
I prefer product.
Then think that way. I'll probably use both. Landon didn't say they needed to have a sum of 7, did he?
They need to add.
They need to add to be 7. Okay? So you want two numbers that multiply to be 12, add to be 7. Now, I know he already gave the pair, and some of you, I could see nod like, oh, yeah, I got it. Some of you may still be thinking, I have no idea how he came up with that. So when I teach this, because we all are going to, this is an easier example, I would say, but we're all going to get those big numbers that are difficult for us that we're just like, I don't know what multiplies and adds to be this combination. So when I do this, I always teach like, okay, let's come up with our numbers that are a product of 12. And I'll always make a list. And I do an orderly list. 1 times what is 12?
12.
1 times 12 is 12. Then I go to 2. 2 times what is 12?
6.
2 times 6. Then I go to 3. 3 times what is 12? 4. Then technically I would go to 4, but what do we notice? We already used 4, didn't we? So those are my 3 options. Which pair adds to be 7? 3 and 4. Now, only thing we haven't discussed is how do we express that answer? Because my answer is not just 3 and 4. I heard it. Parentheses? Yeah. Okay, so I always have us think x squared. How does x squared break up? X squared is going to break up traditionally into x times x. So the beginning of each parenthesis is x and x. The numbers I just came up with, 3 and 4, they go at the end of each parenthesis. So 3 and 4. What kind of numbers multiply to be positive and add to be positive?
Positive.
Positives. So x plus 3 and x plus 4. Now, I wrote mine as x plus 3, then x plus 4. Could you write x plus 4 and then x plus 3?
Yep.
Yeah, it doesn't matter which parenthesis comes first as long as you have the same two parentheses. Okay, questions? Got it? Sound familiar? Okay. Now, one thing I kind of skipped over, which is fine, but one thing you also need to keep in mind is, you guys remember talking about GCFs?
Greatest common factor.
Greatest common factor? You need to keep those as an option in mind. Then you need to be asking yourself, is there a greatest common factor? Okay? That should technically always be our first step, because it can make a difficult problem look much easier. So always be asking yourself, is there a greatest common factor that all the pieces can divide by that I can start? Okay. Number 2. Across the hallway. Okay. Thoughts on number 2? I'm kind of regretting the order I put these in, but that's all right. We'll make it happen.
Looks a little harder.
It is a little harder, isn't it? You know what? Let me skip for a moment.
Good.
We'll come back to that one next. Let's go down here and do this one for a moment. Okay, you have them all in front of you, doesn't matter, right? 3x squared minus 18x minus 48. Good call. I see some calculators coming out. Thoughts on how to factor this? As we finished up the last problem, I suggested you be in the habit of checking for greatest common factors. Is there a GCF that all 3 terms can divide by here? This is why I said I'm glad some of the calculators are coming out, because you're probably going to want to calculate on some of these. Does 3 go into everything?
Yeah.
3 goes into 3. 3 goes into 18. Did you check if you don't know? Does 3 go into 48? It does. So, now when we're factoring, that means I can divide, and I'm going to show it this way for a moment, all of these terms by 3. However, we're not getting rid of the 3. Where do we put the 3 out when we factor it out? We're going to put it outside. So if I have 3x squared, and I divide by 3, what remains? X squared. The 3's cancel. Minus, what is 18x divided by 3? 6x. 18 divided by 3 is 6. Keep the x. Minus, what is 48 divided by 3? 16. Okay. Am I done? What should we check now? Can we do a product and sum like before? And here's what I'm going to say. Maybe we can, maybe we can't, but should we check? Yeah, you always need to check. Uh-huh.
I think I got it.
You think you got it?
Negative 8 and positive 2.
Very possibly. Okay, let's talk about this. And here's the deal, guys. You're going to have to deal with, this is going to frustrate some of you. Okay? I'm not just going to put the answer up here. Because the rest of you are saying, whoa, 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 how did he come up with that? And you talk, we need to talk, right? So you're going to have to bear with me. Sorry. What do we need to find a product of? Is it 48? No, so we're not working with 48 anymore. We're working with 16, specifically what type of 16? Negative 16, yes? So that C value, which is negative 16, and a sum of negative 6. Okay, so we're working with negatives here. When I list my products, I don't worry about negatives yet. Maybe you want to. But I just think, okay, products. What numbers multiply to be 16? I'm always going to start with 1 if I'm stuck and need to know how to make my list. 1 and 16. 2 and 8. 3 and nothing, but I checked, yes? 4 and 4. And right there, since 4 is my other term, that's as far as I can go. Does a pair work here? And I don't see a pair that adds to be 6, but what's the rule when you multiply to get a negative?
You can make one number negative.
Okay, two numbers that multiply to be a negative are a positive and a negative. So if I want a positive and a negative, what happens with 8 and 2 if I make one of them positive and one of them negative? They're then going to subtract to be 6, yes? Which one has to be the negative? 8. And 8 has to be the negative because 6 is negative. And so if 8 is negative, it's the larger number. So negative 8 plus 2. Okay, the deal is, how do I write my final answer? Do I need this 3? Yes. We're factoring. We need all pieces. You don't want to lose any pieces. So I'm going to carry the 3 down. And then I'm going to have my 2 parentheses, yes? X squared is going to break into what? X and X, beginning of each parenthesis. We already agreed the numbers we're going to use are 2 and 8, specifically positive 2 and negative 8. So I'm going to make one parenthesis X plus 2 and the other parenthesis X minus 8. Now am I done? Now we're done. Okay. Does this seem a little familiar if you dig deep enough? Okay. Because a lot of you guys gave me crazy looks when we first started today, but some of the basics are coming back, right? Okay. Let's go up to the one I skipped earlier. 2x squared minus 5x minus 3. What was our first question we had to use on this last problem? Is there a greatest common factor? Is there a GCF between 2x squared minus 5x and minus 3? Unfortunately, no. That would make life a lot easier. Okay. How is this problem different from the original one we factored? How's it different? Why are we not jumping into where to go with this one? Both the last two, when we went to the factory and doing our product and sum, what did they start with? X squared. Does it start with x squared? It does not. It starts with 2x squared. Okay, guys, we can't use the exact same method as last time. We have to change it up a bit. Now, this is where, I don't know what Mr. Weaver teaches. Wait, you guys had Mr. Weaver for Algebra 1, yes? Well, okay, sorry, the sophomores. The juniors and seniors, you guys had Mrs. Rogers, right?
Nope.
Sorry. In my brain, I was thinking about the sophomores. Who did you guys have? Because I know the juniors and seniors, you know, there hasn't been a change there lately. So, okay. I teach product of AC here. Mrs. Rogers does not. She teaches what she called the X method.
Yeah.
Now, I honestly don't exactly know how the X method works. I think there's similarities, but I teach product of AC, and this is where I'm not sure what Mr. Weaver teaches. So he may teach the X method with Mrs. Rogers, he may not. I don't know.
Could have asked Aaron for that.
Yeah. Well, once we get into this, some of the sophomores will be like, yeah, I haven't seen this, or yes, I have, so. Okay, product of AC, guys, here's the deal. It's because of this 2x squared, and I use this anytime I have an A value. So remember, this is ax squared minus bx, well, technically it's plus bx plus c. So when I say product of AC, what are my A and C values in this problem? 2 and what? 2 and what?
Negative.
Okay, I got it eventually. And 2 times negative 3 is negative 6. So I'm going to need a product of negative 6. It's still going to be a sum of B. What's my B value? Negative 5. So we're still doing the same type stuff here, yes? The difference is that for my product, I'm doing AC. Okay, guys, what type of numbers multiply to give me a product of 6? 1 and 6, or 2 and 3? This is the tricky type. When you have a product of 6 and a sum of 5, it could go either way. You have to watch your signs. He says it's 1 and 6. Agree? Disagree? Not sure yet?
Negative 6 and positive 1.
Okay, here's the deal. When you multiply to be a negative 6, you need a positive and a negative, yes? When we add a positive and a negative, are we actually going to add them? No, a positive and negative are actually going to end up subtracting. Okay? So, with that in mind, we have to use the 1 and 6. I want to add to be 5, so I'm going to say positive 1, negative 6. Now, here's the other thing. We can't just put this straight into parentheses and be done at this point. Okay? There's a little more to it. And so, I'm running out of room here. What we're going to do with this 1 and negative 6 is we're going to use it to split our middle term. I feel like I didn't leave myself enough room. So, the first term of 2x squared is just going to carry down. Now, my minus 5x is going to split using the 1 and negative 6. So you can either split it into plus 1x minus 6x, or you can split it into minus 6x plus 1x. Order doesn't matter. The more you get into this, you'll come up with what you prefer. You'll be able to kind of think which one you prefer. I'm going to go ahead and say plus 1x minus 6x. And I still have to carry down that minus 3. So I took my middle term with negative 5x, and I split it with my numbers I came up with, 1x and minus 6x. Okay, I have how many terms here? 4 terms. So when I have 4 terms in factoring, we often can factor by grouping, which is what we're going to do here. So I'm going to take, I'm just kind of giving you a line there, I'm going to split this into halvesies. Okay? We're going to have the front half and the back half. First thing I want to ask you, so forget the back two, 2x squared plus 1x. What's their GCF? What can 2x squared and 1x both divide by? 1 what?
X.
1x. Do they both have an x in common?
Yeah.
Yeah. So I'm going to, and I'll put the extra step in here for right now, I'm going to divide these both by x, which means I'm going to factor an x out front. So I'm going to put x out front, and then whatever remains is going in my parentheses. So what's 2x squared divided by x? Basically an x cancels, and I'm left with 2x. Because a 2 is just divided by 1. X cancels. Plus, what's 1x divided by x? X cancels, and you're left with 1. Repeat this process on the second half. So ask yourself now, what do negative 6x and minus 3 both divide by? 3, preferably of the negative variety. And here's what I'm going to say, is I need some matching to happen. And I'll explain that in a moment. But if this first term here is negative, I'm going to factor out negative. So we're going to divide both of these pieces by negative 3. Now, this you know how earlier I put the x out front? Here I'm going to put a minus 3 after the previous parenthesis. Negative 6x divided by negative 3. What remains in the parenthesis? 2x. Minus 3 divided by minus 3? Plus 1. Okay, guys, we're on last step. Good news. What do you notice? These parentheses match. That is awesome news, because that means I've done it right. Okay? If my parentheses don't match, somewhere you made a little mistake. Even if they are just a single negative sign different, you've made a mistake. My final answer is going to be 2 parentheses, just like my other answers were today. What is my matching parentheses? 2x plus 1. So my matching parentheses are in common. So I'm going to pull out 2x plus 1. What are the remaining pieces?
X minus 3.
The GCF of x and the GCF of minus 3. Okay. I know it's different than the x method. This is what you did with Mr. Weaver? Okay, good to know. I don't think Mrs. Roger teaches product of AC at all, so. And this is just what I've always taught, so I've never really, I'll be honest, I've never really tried to learn the X method, so.
I like forgetting.
And that's the thing. If you can figure out how to do the X method and you still want to use it, I'm not going to argue. Okay? They're both legitimate methods. Okay? So. Now, something I should probably talk about at some point. How can we check our answers? I'm trying to think, have we done this year? I'm not sure we have. What? FOIL? Do you guys remember FOIL? How do we multiply them back together? You FOIL, right? First, outside, inside, last, or it's fancy for distribute, right? Okay, so I could check myself. 2x times x is 2x squared. 2x times minus 3 is minus 6x. 1 times x is 1x. Well, minus 6x and 1x is negative 5. 1 times negative 3 is negative 3. Okay? Okay, guys. Product and sum, GCFs, product of AC. Those are all going to be big. Now, I have one special case I'm throwing in that the book threw in. It's a good one to know, although I'm not sure you're going to see it much in the homework or anything. X squared minus 9 is a special case. It's not exactly product and sum. It's definitely not product of AC. First question, is there a GCF? I'm trying to get you to think that in your brains. Do you remember something, Landon?
Square root.
Square root? How do we put our answer? Okay, so this is what I call, the official name of this is difference of squares. Okay, the fact that Landon sees square roots, he's on the right track. This is difference of squares because x squared is what I would call a perfect square. 9 is what I would call a perfect square, and the difference just indicates that this is subtraction. So we do want to think about that.
I think I remember what the answer is.
Okay?
I think it's the square root of 9 is 3, so I think it's x plus 3 and x minus 1. Or x minus 3 in parentheses.
Okay, I think you might have it now. And here's what I'm going to do. Okay, guys? Can we do the square root of 9? Square root of 9 is 3, because what number times itself is 9, yes? Now, officially, we're doing this also. What is the square root of x squared? In other words, what number times itself is x squared? And that is x. Okay, if those things both check, yeah, we can set this up into 2 parentheses. Like I said earlier, x squared, how does x squared break up? X and x, front of the parentheses. What goes in the back of the parentheses? Square root of 9, which is 3 and 3. And then what I always ask here, how do you multiply to get negative 9? You need a positive and a negative. Now, part of the reason this one is different, because you're going to get a positive 3x and a negative 3x, my middle terms are going to cancel, aren't they? Okay? Okay. Let's go down to the next one, which I moved to the next page. I'm glad I have that set up that way, because I think I might make that a little bit bigger, though, because what just happened? It like has a mind of its own. Okay, there we go. I was trying to move it, but it just kind of like glitched and moved on its own. Okay, 5th example. 3x squared minus 7x plus 2. What's your first question? Does it have a GCF? No, 3, 7, and 2 don't divide by the same thing. That would be too nice to happen, wouldn't it? So, can I just set up 2 parentheses like this and do product and sum? No, why not? Because there is an A value, yes? Because there's an A value, we can't just go product and sum. We have to go product of AC. Okay. Product of AC. What are A and C? 3 times 2, which is 6. A sum of B. What is B? Negative 7. Okay. Again, this is an easier one in terms of pairs. What multiplies to be 6 that somehow is going to give me 7? Yeah, multiplying to be 6 is 1 and 6 or 2 and 3. Well, the only way I can get it 7 is to use 1 and 6. How do my signs work here? Both negative, yes? If you multiply to be a positive, they're both the same sign. Since they add to be a negative, both negative. Okay, guys, what do I do with that negative 1 and negative 6? We're going to split that middle term. Practice this with me, because this is the piece that people always forget. So 3x squared, I'm just going to carry down. Minus 7x. And this is as you look ahead at factoring your groups, you can decide, do I want to put minus 1x or do I want to put minus 6x first?
6.
I was kind of thinking about changing it up this time and doing the minus 6x, just so I can. So I'm going to put minus 6x and then minus 1x, and of course at the end is plus 2. Okay. Good rule of thumb to be in when you have 4 terms. Think in terms of factoring by grouping. I'm going to split it into 2 halves, and I split it right after the 6x. GCF of 3x squared and 6x. They both divide by 3, and they both divide by x, right? These first 2 will always divide by an x. So we're going to divide by 3x. Now, what do I do with that 3x that I'm dividing by? I'm going to put it out front. Can't just drop it off. 3x squared divided by 3x. X. 3 divided by 3 is 1. 1x cancels, so we have x. Minus 6x divided by 3x. Okay, minus 2. 6 divided by 3 is 2. X's cancel, so it's a minus 2. Okay, second half. Minus 1x plus 2. GCF. Yeah. If all else fails and you're thinking 1x and 2 don't have anything in common, what's always a common factor if all else fails? 1. Now, why do we want to go negative here? Because I need this negative to be gone, and honestly, if you start looking to pair up, I'm going to need my 2 to be negative. So I need to divide by a negative to make that happen. So factor out the negative 1, write down that negative 1. Negative 1x divided by negative 1 is positive x. 2 divided by negative 1 is minus 1. Oh, 2 divided by negative 1 is negative 2. Don't ask. I don't know. I don't have a good answer there. I made a careless mistake just like you guys do, right? Honestly, I didn't even catch it until I heard someone say, what? Okay. Do you think I was successful?
Absolutely.
Yes, because my x minus 2's match. Now, is this my final answer? No. Please don't stop there and lose yourself a point for something so silly. Matching parentheses. X minus 2. That's a GCF. That's one of my parentheses. My other parenthesis. The leftovers are the other GCFs of 3x minus 1. Okay, we've got one more problem we're going to do. And yes, we can do it today. Okay. We are, but we're going to make it happen. What's my first question? What's your first question? Is there a GCF?
Yes.
Yes? That makes life nicer.
2.
What do they all divide by?
2.
2. Aren't they all even?
Yes.
2.
Yeah. So if we're going to divide these all by 2, that means I'm going to put 2 out front. Divide them all by 2. 2x squared divided by 2 is x squared. 4x divided by 2 is 2x. Minus 126 divided by 2. Minus 63. By dividing out that GCF, I just changed this problem totally. It looked like it was going to be product of AC, didn't it?
Yes.
Do I have to do product of AC? No, in all honesty, you can. But what I know is I can just keep this 2 out front, and then this piece right here, I can go for my 2 parentheses. Just regular product and sum. X squared breaks into what?
X.
X and X. Now, we need the numbers, yes? Some of you have them. Awesome. For the rest of us that don't have them, we need a product of what? Negative 63. So we have to multiply B negative 63 and add to B 2. Well, if you know your math facts, you have something that comes to be 63 in your mind. If not, you're going to start trying them, right? 1 and 63. 2 and nothing, it's odd. 3 and 21. 4 and nothing. We can pretty much eliminate the 4s because it did, or the evens, because it didn't divide by 2, so all evens are out. So no 4. 5? No. Doesn't end in 5 or 0. 6? It's even. No. 7? 7 times 9? That's a pair you should know. Okay. How do I make this 7 and 9 happen?
need the 7 to make it is.
7
Okay, it multiplies to be negative 63, so I need one of each. It adds to be positive 2, so my larger number is positive.
Ka-chow.
Told you we could get that last one in.
plus 2 easy.
Okay, so I expected to get a lot more than 6 problems done today. Yeesh. Okay. This lesson may take me a little longer than I expected. Okay, the homework will be out there. Right now, there's a few factoring problems, but on Monday we'll move into how to use factoring to solve an equation. And a decent amount of them are that. So you're welcome to look at it. You're welcome to not worry about it. I have it as due on Tuesday. That would be assuming I finish the notes on Monday. Okay? So,
Oh,
part 1.